Okay, for this example, we want to verify that cosine of x over 1 minus sine x, that's one big fraction, equals 1 plus sine x all over cosine of x. This is the first one we come to, I think, that are absolutely equal, left and right. And when they're absolutely equal, have the same number of trig functions, they both are fractions, they look about the same level of difficulty, there's a good chance that it doesn't matter which side you start on. You're going to have an equal chance of getting it either way you go. So we just need to pick one. So is it okay if I just pick the left? Okay, so we're going to work on the left side. And let's just talk about it a little bit and see what our options are. First thing I'm going to ask you is this. Can I split that into two separate fractions on the left side?
Yes. No, not on the left side.
Why not?
Subtractive.
Because
The denominator is also cosine.
Well, because there's only one. It's the numerator's not a binomial, so you can't split it.
right. It's okay if it's subtraction. Like you can split them whether they're addition or subtraction. Didn't we just split the last one with subtraction? I don't know.
Yeah, you can split
And then
them.
I don't remember what. Okay, say that one more time.
The numerator is not a binomial.
Right. See, okay, look at the left side versus the right side. The right side of this could be split. It could be split into 1 over cosine plus sine over cosine. But the left side can't. You can only split the numerator, not the denominator. Now you can split the numerator across addition or subtraction, but you can never split the denominator. So we can't split it into two separate fractions. We don't have any Pythagorean identities at work. We don't even have any squares. It already has a common denominator. There's nothing to factor. There's nothing to distribute. It's already sines and cosines. That sort of talks us all the way through that list of things. But there was one thing on that list at the very, very bottom. What was it that we said we only use if we're out of other options? We can break out the conjugate and use it, okay? Also, you can almost always see when you need a conjugate because the conjugate will appear on the other side. Look. For the binomial on this side, we have 1 minus sine x, and on this side, we can see the conjugate, which is 1 plus sine x. So the only way to get that 1 plus sine x up there is to multiply by it. So let's try that. Let's take the left side, cosine of x, over 1 minus sine of x, and let's, out of thin air, this is the part people don't like, you just make it up, and we're going to multiply top and bottom by the conjugate of that binomial. So the conjugate is what? 1 plus sine x.
We just flip it.
We're not flipping it. You're not allowed to flip it. You're not allowed. You mean we want to flip the fraction?
Oh, it's like when you
No.
got binomials. It's just the opposite of the denominator.
Right. You just multiply by the opposite of the binomial. So you keep the whole thing, then you just make up the conjugate and put it on top and bottom. Just like when you're rationalizing complex numbers.
Yep.
2 plus 3i, you multiply by 2 minus 3i. Yeah. Okay, now here's the trick, and if you don't learn this trick, you're going to mess it up every time. We could distribute the top and the bottom, but you don't want to. You want to leave that 1 plus sine x alone so that it will show up there. Okay? You only want to FOIL or distribute the two that are conjugates. Leave the other side of the fraction undistributed. So what we're going to do is we're going to leave the top, cosine of x, and put parentheses around the 1 plus sine, but we are not going to distribute. We are, however, going to distribute the two that are conjugates. If I multiply 1 minus sine x times 1 plus sine x, if I FOIL that out, the outer and inner terms will go to 0. We'll do 1 times 1. Outer times outer is positive sine x. Inner times inner is negative sine x. Those cancel. And last times last is negative sine squared of x. And that's why we use conjugates. That will always happen. Your outer and inner terms will go to 0. So that brings us up to here. Now the nice thing about this is most of the time when you use a conjugate, it will turn into an alternate form of a Pythagorean identity because the things will be squared because of the way conjugates FOIL out. 1 minus sine squared is exactly equal to cosine squared. Because of that Pythagorean identity, sine squared plus cosine squared equals 1. So you go off, you rearrange it, and you see that 1 minus sine squared is cosine squared. So we can substitute this quantity here, or we can remove it and substitute cosine squared. Once that happens, I can reduce the top and bottom by a factor of cosine. One of the cosines will cancel, and I'm left with 1 plus sine over cosine, right? Because this is factored out, you're allowed to go ahead and cancel that. So you have 1 plus sine over cosine, which is exactly what I need on the right side. So that one's pretty simple. People don't like that because you have to introduce that conjugate and it kind of feels like you're pulling it out of thin air. But once you get used to seeing that, if you see 1 plus sign on one side and 1 minus sign on the other, you probably know it's going to be a conjugate problem. Okay, so occasionally you'll run across a problem where you'll pick a side, you will work on it and work on it and work on it, and it will never work. You know, you won't quite be able to ever get it to equal the other. If that happens, you don't have to erase everything. You can just stop working on that side and go work on the other. And you can work until the two sides are equal. So the last step that you leave on both sides has to be equivalent in order for you to get credit for this method, okay? So if you work too far, then just erase off the steps until they're equal. Or if you work one side, go work on the other, and they're still not equal, go work on the other side some more. But you can only work on one at a time. Does that make sense? Okay, let's take a look at one. This one's bad. That little symbol there, that's an alpha. That's a baby alpha, the Greek letter alpha. Looks a little like a Jesus fish, yeah? What's that called? It has a name. And
Ichthus.
Ichthus. Is that what you said, ichthus?
I don't know, I never
Okay,
really had a name.
anyway, it looks like one of those, but it's actually a baby alpha. Okay, so we want to verify that these two sides are equal. And they both look pretty bad to me. I think I want to start working on the right side just because that right side looks like a trinomial, and for the first time I think maybe we can factor it. So I'd like to kind of play around with that and see if we can make it factor out, okay? Let's see, I think this might take a little room, so let me move it up a little more. There we go. Do you guys mind? Let's start playing around with the right side. Okay, let's take a look. On the right side right now, we have 1 plus 2 sine of alpha plus sine squared of alpha all over cosine squared of alpha. I know, I feel the same way. Okay, so I think that'll factor the 1 plus 2 sine of alpha plus sine squared of alpha. I don't know, let's play with it. You want to? Okay, let's see. That would have to be a 1 and a 1, and then sine can only be split into sine and sine. All right, let's see if that works. Last sine's plus, they both take the middle. Let's see, that's 1 plus sine alpha is 2 sine alpha plus sine squared. So that does work. Yes? Okay, and on bottom, I have cosine squared. Does that make sense to everyone? Hang on one second. All right. Does anyone have any ideas for where to go from here?
You can go back to your sine, your Pythagorean identity. Cosine squared is going to be 1 minus sine squared.
Right. Do y'all see that? I don't know what else to do. The only thing I could think of at this point
So you
is
can
to
then
say,
factor out and cancel out, and you can have a 1 minus sine on top.
right.
And that's it.
Yeah, I think you're right. I think that's about as far as you can go. Did anybody have a question before we moved on?
Can you rearrange the top to where it looks like a normal?
Oh, you mean to put the sine squared first?
Yeah.
Yeah, you can. I just don't ever, in Algebra 2, I don't teach it that way. I just factor it however it shows up, and I don't worry about it. But you are allowed to rearrange the trinomial into a better form if you like before you factor. A lot of times the 1 does come first in trig, so through the years I've just gotten used to seeing it if the 1 is first, factoring it. Okay, so what you were saying is that we could take the cosine squared and we could substitute 1 minus sine squared, which seems like it's making it worse, but I think it actually might make it better. Let's try it. 1 plus sine of alpha times 1 plus sine of alpha all over, cosine squared is the same as 1 minus sine squared.
So it's 1 minus sine 1 minus sine
Alpha.
times 1 plus sine.
Right.
So then
So that's your difference of two squares. So let's do that right now. So we're going to factor the bottom now into the difference of two squares. And I think you're right. I think something's going to simplify then. So 1 minus sine squared is the same as 1. And see, this is why I don't rearrange them, is when the minus is, I don't want the minus first. Does that make sense? So I like for that 1 to come first in this case. I don't like to always rearrange them. 1 plus sine, 1 minus sine. And sure enough, this will simplify to 1. And then we're left with 1 plus sine over 1 minus sine. At that point, I have no idea where to go. None. So this is the part where I just kind of got to it. I think I was working on it a couple of nights ago. I got to this point and I was just like, okay, I'm going to stop. I'm going to go work on the other side because I just didn't know what else to do. Okay? All right. I did notice this, however. I noticed that the right side is one big fraction. Do y'all see that? So I wanted to take the left side apart, but I avoided that. Like I wanted to split that left side into two different fractions, but when I realized that the right side is one big fraction, I decided just to leave it. So what I thought maybe we should do is take that left side and change it all to sines and cosines. So let's try that. We have 1 over cosine plus sine over cosine over 1 over cosine minus sine over cosine.
Just a reminder to.
Okay, let's try that again. So we're putting everything in terms of sines and cosines. We have 1 over cosine alpha plus sine of alpha over cosine of alpha all over 1 over cosine of alpha minus sine of alpha all over cosine of alpha. Now avoid the temptation here to try to cancel something. Those are both binomials and you can't cancel unless you can cancel from all 4 of them. So be very careful with that. What we can do is multiply top and bottom through by the common denominator of all of the terms and simplify that complex fraction. So I'm going to multiply everybody through by cosine of alpha. We're going to multiply by cosine, multiply by cosine, multiply by cosine, and multiply by cosine. Then if I go through and I simplify everything, these two cosines reduce to 1, and I have 1 plus these two reduce, so I only have sine of alpha left. And sure enough, that's what I stopped with over here. All over, these cosines cancel, and I have 1 minus, these cosines cancel, and I have sine of alpha. And if we look at that, that's exactly what I had when I stopped on the right side. So now that the two sides are equal, I can call this problem finished. And that wraps up section 5.2.